Hello, it's me, Mr. Werger. Today's lesson is on limits. This is the first of a couple lessons we're going to have, kind of giving you a preview of calculus. So limits is a very key concept that many other calculus concepts build off of. Okay? The first part of this lesson is some factoring review. So factoring will be a key skill to some of the limit problems that we do. So I want you to factor these. Why don't you hit pause and try those on your own. And here's a hint. They all factor, and they all factor the exact same way. So given that, see if you can factor those. Hit pause or hit play again when you're done. Okay, so you factored expressions like the first couple there many times. These are difference of squares problems. So they're all subtraction and they involve perfect squares. So the square root of x squared is x. The square root of 9 is 3. And then if these are going to multiply to be negative 9, one of them would be positive and one of them would be negative. The factors are conjugates of each other, which we've seen throughout the year. That's why there's no middle term when you FOIL. You got your x squared, you got your minus 9, but negative 3x and positive 3x add up to 0. Okay. So number 2, the second one is also pretty straightforward. Square root of 64 is 8. So x plus 8, x minus 8. Okay. So then if we do the same thing with these next examples, so the square root of x squared is x. And then we've got the square root of 14. And that cannot be simplified, so we'll just write it as plus or minus the square root of 14. When you multiply those together, you'll get negative 14, right? And so factoring does not necessarily need to involve integer values. We can factor with some irrational values there. So then the next one is the same idea. X plus the square root of 37, x minus the square root of 37. Oops. Next one. So 4 is a perfect square, plus 2 minus 2. So these first terms would have to multiply together to be x. So if I multiply the square root of x times the square root of x, that would give me x, right? So there might be a problem or two you come across where it would be useful to factor this into these factors. Okay, then the last one here, so the square root of x to the 8th would be x to the 4th. X to the 4th times x to the 4th is x to the 8th. We can keep going with this one, so we've got x to the 4th minus 1. So that factors x squared plus 1, x squared minus 1. So I've got this, I've got this. So when it's addition, then they don't factor. It's got to be the difference of squares. Only the subtraction ones factor. So now x squared minus 1. That's x plus 1, x minus 1. Okay, so then if I just bring down these previous factors, so that would be my answer right there. X to the fourth plus 1 times x squared plus 1 times x plus 1 times x minus 1. Okay? So kind of keep that in the back of your mind, and if you've got something that involves factoring, this might come in handy. Okay? So we are talking about limits. So this is the notation for limits. So they use the abbreviation LIM, lim. That's short for limit. Underneath it, it's got an X and then an arrow and an A. So this is the limit as X approaches A for a given function, f of X is equal to some value L. Okay, so what this means, if we kind of wrote out in words, like what this expression means, as X approaches A, so that's the part on the bottom here, as X, and then the arrow, so as X approaches A, the value of the function f of X approaches L. As X approaches A, the value of the function f of X approaches L. Okay, and the key word there for limit, kind of the key to understanding limits, is this word approaches. So as you approach something, what are you doing? If I am approaching the camera, so that means I'm going to get closer and closer to the camera. I'm approaching it. So I'm getting closer and closer. I don't know what this is going to look like. I don't want to freak you out. So if I'm approaching, I'm always getting closer and closer and closer, right? But theoretically, I never get there. If I'm approaching, I'm always getting closer, but I'm never really getting there, okay? It's probably much closer than you ever wanted to see me, right? So approaching gets closer, but you never get there. Okay, that's kind of the key idea. Because once you get there, then you're not approaching anymore, right? Then you have arrived. So approaching does not include an arrival. Approaching is just getting closer and closer and closer. And like part of calculus is the idea that you can always get closer than where you are. So if I'm a millimeter away, I can get a half a millimeter away. If I'm a half a millimeter away, I can get a quarter of a millimeter away. And it's going to be like a smaller and smaller fraction of a millimeter, but however far away I am, I can always like cut that in half and still not be there. Okay, so it's possible in the world of math to always approach something, but never to get there. Okay? Okay, so we have a graphical example here. So this is just some random function, f of X. So first part says find f of -2. Okay, so that's not a limit, that's not calculus, that's just basic algebra, right? Find f of -2. So when the x value is -2, what is the value of the function, or what is y? So look at your function here, x is -2, point right there. Looks like y is 3. Okay. Nothing earth-shattering there. Okay, so then let's look at the limit as x approaches -2. So maybe picture the function as like a road. So you're on this road, it's got some hills to it, whatever. So you're on this road and you're getting closer and closer and closer to -2. Okay, but you never get there, but you're gonna get really, really close to it. And you can approach -2 from either side here, and you're gonna approach the same point, right? So as you approach -2, what value are you approaching? So in this case, you're approaching a y value of 3. Okay? Don't worry, it gets better. So now let's look at f of 2. So the value of the function when x is 2. So I'm looking at when x is 2 and I see an open circle there, which we remember from earlier in the year represents removable discontinuity. Remember that? So there's a point missing there. Okay, and I don't see any other points when x is 2. So f of 2 is undefined. F of 2 is undefined. When x is 2, there is no y value. Okay, how about the limit as x approaches 2? So I'm approaching 2, I'm getting closer and closer and closer to 2. I'm never going to get there, but I am approaching what y value? So I'm approaching 1. I'm never going to get there, but with a limit, you never get there. You just get really, really close. As close as you can possibly be without actually getting there. Okay? Okay, so kind of the main point of these two examples. So at -2, the function is continuous. Okay, there's no holes, there's no asymptotes, there's no jumps or anything. So if a function is continuous at a given x value, then the limit is going to be the same as the value of the function. So at -2, it was continuous, so these are the same. Okay, so we'll write that down. Since the function is continuous at x equals -2, these are the same. Okay. If the function is not continuous at a given x value, so the function is not continuous at 2, so then the value of the function and the limit, those will be different. So yes, let's say since the function is not continuous at x equals 2, these are not the same. Okay. Okay, so most of the problems you'll be doing on your homework, you're not going to see the graph, you're just going to see the function. Okay, I'm hoping that with at least some of these, the functions are somewhat recognizable. So x squared minus xs plus 10, I would hope you would immediately say, boom, quadratic. Graph is a parabola. So are parabolas continuous? Parabolas are continuous, right? There's no holes, there's no jumps, there's no asymptotes. So this function is continuous for all values of x. Okay, so the limit as x approaches 2 will be the same as just finding f of 2. So to evaluate this limit, we just plug in 2 for x. 2 squared minus 6 times 2 plus 10. Four minus 12 plus 10. Looks like 2. Okay. So that's going to kind of be our approach. So now we get to something more complicated. The sine of 3x over x. So we're going to assume that it's continuous at this x value until we find out otherwise. Assume it's continuous at x equals pi until you find out otherwise. So if I'm assuming it's continuous at x equals pi, then I'm just going to plug in pi for x. So that would give me the sine of 3 pi over pi. So here's where all that trig stuff would come in a calculus problem. So the sine of 3 pi, not too tough. Pi, 2 pi, 3 pi, so we're talking about this spot on the unit circle. Coordinates there are 0, no they're not. Coordinates there are -1, 0. Sine is the y coordinate, so that would be 0 divided by pi, which is 0. Okay, so even though we're not really familiar with that function, I mean, we could graph it and kind of look at the graph, but just trying to plug in the value that x is approaching. If it's continuous, then that's all you got to do. Okay? Okay, so we'll do the same thing. So here we'll try plugging in 2. I'm going to assume that it's continuous at x equals 2. So if I plug in 2 for x, so I would get 2 squared minus 2 times 2 over 2 squared minus 4. Okay, so that's 4 minus 4 in the denominator, 4 minus 4 in the numerator, so that's 0 over 0. Okay, So the value of the function at x equals 2 is undefined. Okay, that's not the answer. So we're looking for the limit. Okay, so if this has been a graph, it's like, okay, we just found f of 2. And f of 2 was undefined. Okay, just because that's undefined doesn't mean the limit is undefined. Okay, so we've got to take the next step. So if we get this, so this is not the answer. So when this happens, we're going to try factoring. That factoring at the beginning of the lesson wasn't just for fun, it was for a reason. Okay, so if I factor this, so the numerator, greatest common factor there is x. So I can factor out an x. The denominator there is a difference of squares, x plus 2, x minus 2. Okay, so we factor, and then we hope that it simplifies this in some form. So in this case, the x minus 2's cancel out. Okay, so now you're just left with x over x plus 2. Okay, so now plug in 2 for x. And now it's not going to be undefined anymore, right? Now plug in 2 for x. So we get 2 over 2 plus 2. Which is 2 over 4, which is 1. Okay, so the value of the function is undefined, but we're doing limits. So the limit, as we get really, really close to 2, the value of the function is going to get really, really close to 1/2. Okay. Okay. If you'd like to hit pause and try the last example on your own, go for it. All right. So if you plug in 1 to the 4th minus 1 over 1 squared minus 1. So that's 0 over 0. And so f of 1 is undefined. We're looking for the limit. So factoring, we saw this at the beginning of class, that factors into x squared plus 1, x squared minus 1. Oh, look at that. We've got x squared minus 1 in the denominator. So, I mean, you could keep going with factoring x squared minus 1, right? Or you could just stop and say, those cancel. So now if I plug in 1, I've got 1 squared plus 1. So 1 plus 1 is 2. All right. So that's an introduction to limits. There's much more to limits than what we have here. We'll do more with limits next Monday. The homework is worksheet 24 in your packet. And then if you missed class today, you missed the EMPT test. So we're gonna have to find a time next week for you to set aside 45 minutes to take that EMPT test. So I guess kind of look at your schedule and see when you will be able to do that. All right. Have a nice weekend, and I will see you next week.